Hello friends, so here in this problem we have to evaluate limit x tends to infinity, x in the bracket square root of x square plus 1 minus square root of x square minus 1. Now before starting with the solution, if we will observe the given limit, then here we have x tends to infinity, and whenever we have infinite limit, then we substitute x as 1 upon t to make it finite. So here I will put x equal to 1 upon t everywhere. So when we will substitute x as 1 upon t in the function, that function will shift from x domain to t domain. So whenever it will shift from x domain to t domain, that time we want limit for t domain. So let us find the limit for t domain. So when x is infinity or x tends to infinity, here we will get infinity equals to 1 upon t. And we know that by the rule of mathematics that we get answer as infinity if the denominator is 0. So if x tends to infinity, it means t has to be 0. So here I will say as x tends to infinity, t tends to 0. So here we got limit for t domain. So therefore this limit L will become t tends to 0. This x is 1 by t, inside the bracket square root of 1 upon t the whole square plus 1 minus square root of 1 upon t the whole square minus 1. Now therefore we will get L as limit t tends to 0. This is 1 plus, this is 1 upon t square plus 1. So that is square root of 1 upon t square plus 1. Here square root of 1 upon t square minus 1, and outside this bracket we have 1 upon t. So after taking LCM, here we will get L as limit t tends to 0, 1 upon t as it is. This will become square root of 1 plus t square upon t square minus, this will also become 1 minus t square upon t square. So now after taking the square root, here we will get L as limit t tends to 0, 1 by t, in the bracket we will get square root of 1 plus t square, and square root of t square is t, minus square root of 1 minus t square, and square root of t square is again t. So from this both term we can take t common, and this t which we are taking common will multiply this t which is outside and will get t square in the denominator. So therefore L will become limit t tends to 0, square root of 1 plus t square minus square root of 1 minus t square upon t square. And now if you will observe the function, then here we have algebraic function where limit t tends to 0, and whenever we have algebraic function we apply direct method, and if by direct method we get 0 upon 0 or indeterminate form, then we look for some other method to evaluate the limit. So first of all I will start with direct method. So therefore by direct method, here we will get square root of 1 plus 0 square, that is 0, minus 1 minus 0 square, that is again 0, and 0 square is again 0. So here I am applying direct method, and if you will observe, then square root of 1 minus square root of 1 is 0, whole divided by 0. So we are getting L as 0 by 0. It means here we are getting indeterminate form. So whenever we get 0 upon 0, that is indeterminate form, by direct method, we say direct method fails. So here direct method fails. And whenever direct method fails, we look for some other method to get the value of given limit. So here we'll again observe the function. So in this function, in the numerator, we have two square roots with minus sign in between. So whenever we have square roots and if we want to remove square roots, we use method of rationalization where we multiply the term with the conjugate of it. So here I'll say by method of rationalization we will get L as limit t tends to 0 square root of 1 plus t square minus square root of 1 minus t square upon t square. Now here I am performing rationalization, so I will multiply this numerator with 1 plus t square plus root of 1 minus t square. Similarly, I will multiply this denominator with 1 root of 1 plus t square plus root of 1 minus t square. So after this, if you will observe the numerator, then here we have this form a minus b and a plus b. So here we can apply the formula, that is a minus b into a plus b is a square minus b square. So by applying this formula, we will get L as limit t tends to 0 square root of 1 plus t square the whole square minus square root of 1 minus t square the whole square, and denominator will remain as it is. So t square into square root of 1 plus t square plus square root of 1 minus t square. So now we will get L as limit t tends to 0. Here this square and square root will be cancelled and we will get 1 plus t square here and 1 minus t square in the second bracket. So 1 plus t square minus 1 minus t square upon denominator will remain as it is. So denominator is t square into root of 1 plus t square plus root of 1 minus t square. Next, if you will observe here, then due to this negative sign, 1 will become negative and we can cancel this plus 1 and minus 1. Similarly, this t square will become positive t square and here we will get t square plus t square as 2t square. So therefore L will become limit t tends to 0 2t square whole upon t square into square root of 1 plus t square plus square root of 1 minus t square. Next, we can cancel t square from numerator and denominator. So we will get L as limit t tends to 0 2 upon square root of 1 plus t square plus square root of 1 minus t square. And if you will observe again, then again we got algebraic function. So here we will again apply direct method and we will check what we are getting. So by direct method we will get L as 2 upon square root of 1 plus 0 square, that is 0, plus square root of 1 minus 0 square, that is 0. So here we will get 2 in the numerator, square root of 1 is 1 plus square root of 1 is 1, that is 2, and we will get the value of L as 1. So the value of given limit is 1. Thank you.